Hello, everybody. It is great to be here at Star Trek. I am very honored that you all chose to spend this session here with me. Now, if you're either here in this theater or in one of the adjacent ones, it's most likely because you've gone through your company's internal security review process at least once. Maybe because you were told you had to, or because you were trying to do the right thing and solicit a security engineer's advice before you launch something to prod. Regardless of the reason, though, it's probably sucked at least once. Maybe it has taken forever just to get your security review prioritized. Or once it's already been prioritized, maybe it drags out because your security engineer keeps getting distracted or pulled away on other items. You probably have gone through what seems to feel like an endless barrage of questions, some of which might not even make sense. And then when you finally get the recommendations or findings, maybe some of them are just irrelevant or they actively contradict what you are trying to build in the first place. Based on the number of people who I see some smirks here, it sounds like this sounds familiar. And unfortunately, this is pretty common, especially now with all of the emergence of AI-assisted development tools. Some of these challenges actually stand to get worse before they get better, both because feature delivery is accelerating, but also because the size of those features is increasing. Now, if going through your security review process already sucks, let's talk about what we can do to make that better before it sucks even more. And to be perfectly clear, this is not just a one-sided effort. It's not that all of the work falls on the engineering teams to make this better. Security teams have a lot of work to scale their processes as well. However, in the meantime, before that happens, with this being a developer conference, we're going to talk about what developers can do to make this better, at least in the meantime. Before that, I do want to introduce myself. So I'm Jamie Dicken, and I am the Senior Director of Product Security at GitLab. One of the teams that I lead is application security, and a large part of their remit is conducting security reviews of new features before they go to production. Now, before that, I led application security and infrastructure security at New Relic, and so I've been in the security review world for a while now. But while the second half of my career has been focused on security, I actually started my career as a software engineer and a software engineering manager here locally. And let me tell you, sometimes I hated working with security teams. It felt like sometimes they were blocking me more than they helped. It felt like sometimes they were just incentivized to prevent me from shipping anything in the first place. There were times that their advice was wild. Like at one point, my security team literally came to me and said, "We've decided that open source software is too risky and you gotta get rid of it within the next quarter." That did not happen, but it was hilarious. And other times it just felt like they were trying to play a completely secondary product manager when I already had one that I was struggling to serve in the first place. The thing that I realized, though, is that security was becoming an obvious problem that I couldn't ignore. If I believed in the products that my teams and I were shipping, and I really did, I couldn't ignore security and the risk that something bad could undo all of my team's hard work. And that's why I pivoted into security. But it didn't take me long to realize that it sucks on the AppSec side too. So I do want to talk about why. First, AppSec teams normally grow sublinearly to the rest of the business and the rest of engineering. I can't tell you how much it frustrates me every year when these security companies release these state of AppSec reports and it talks about how the ideal ratio of security engineers to software developers is 1 to 25 or 1 to 50 or something like that. I have almost never seen that play out in reality. Now, at a previous company, I had a total of 3 AppSec engineers for 100 engineering teams. The lower your ratio, what that means is that the less context that any of those AppSec engineers is going to have about your system or service, and the steeper the learning curve they are going to face every time they do a review, even if you get the same one on your review, because they have been context shifting. Second, security reviews are only one part of an application security engineer's job. In addition to the other important and time-sensitive reviews that other teams have asked them to do, they're often managing your company's bug bounty programs, triaging vulnerabilities, answering customer inquiries about the vulnerabilities that are still there, or dealing with investigations or security incidents from products across your entire company's estate, not just yours. They also have their own strategic projects and goals too, like trying to fix this problem on their side and figuring out how they have to overhaul their processes to do that. What that means is that their attention is divided. And let's be real, most often, the security review engagement model isn't great either. There are so many times where engineering teams have come to security and they've said, we have this high priority thing, it has to ship tomorrow, we need you to approve it today, and if you don't, we're gonna say that security is the one blocking us. Not great. Also, that same security team, as soon as they pick up the review, they start to dig in and they're trying to figure out what the heck they're even looking at in the first place. And in the back of their mind, what they're thinking is that if they don't find all of the issues, those are then going to either become vulnerability reports or incidents later, and they're gonna be the ones who get paged in the middle of the night or have their weekend plans interrupted. So it's high pressure, and when you get into those engagements, it sucks on both sides. The reality is that the system is actually set up to suck. So over the past years, AppSec teams have tried really, really hard to figure out how to fix this. They've built security champions programs where they engage developer volunteers, or people who are voluntold that they have to do the security things because they legitimately can't do them all on the timeline that you would like them to. If anybody here has been a part of a successful security champions program that has withstood more than 6 months of time, please let me know because I would love to hear about it. Generally, I have not seen those work. AppSec has also tried to make this big move to shift parts of their security review left, so they can do some of the work at design time and then other work following code completion. But this doesn't really work either. So basic math tells us if we start off with a set number of reviews and we cut them in half, but we do twice as many, we actually haven't moved the needle. And really, this is a best case scenario. What this ultimately means is that now that you have twice as many things, now for every feature that you want a security review, there are actually 2 opportunities for timeline delays or security engineering learning curves. So this doesn't work like we want it to either. Now, at the end of the day, the problems that I've outlined really are systemic. And as an individual engineer, you yourself realistically can't change the system all by yourself. However, there are steps that you can take to make security reviews suck a whole lot less, and that's what we're going to turn our attention to today. First, though, we have to understand what a typical security review looks like, because this is going to help give us insight into what we can do better. First, a security review comes in and it finally gets assigned to an engineer. The first thing that they have to do is figure out what the heck they're looking at in the first place. This typically entails reviewing whatever information you've given them, diving into like an epic or a work item or an issue description in whatever tracking system you're using. Then you click on one link that leads to another link that leads to another link, and they're still coming back to you to ask questions because tying all of that information together can be tricky, even when you use AI. Then, once they have an understanding of what you're building and why you are building it, they go the next level deep. And they try to figure out what your high-level system design looks like. They're trying to build their mental model, and they're reviewing your architecture diagrams and figuring out how data flows through your system. With that information, then they build a threat model. And they're looking for things like what could go wrong, they're identifying what problems they should be looking for in your review, and they're constructing what their test plan looks like. Using all of that information, they start reviewing the code to look for obvious security smells, and they refine their test plan. Then they perform a penetration test where they act like an attacker and try to find vulnerabilities. And then when all of that is said and done, they document their findings. So as you can see, security reviews really aren't small activities, and realistically, half of that is just prep work before they can actually begin their review. So hopefully by this point, we're starting to already see some possible areas of improvement. So I first want to take a look at at a couple of these prep work steps. The first area where we can make a difference to make this suck less is with context ramp up. This is a non-trivial level of effort for a security engineer to take something that they haven't seen before, that you've been pouring in days, weeks, maybe even a couple of months to build, but it's absolutely critical for that review to be successful. I want to leave the world of tech to prove that point. All of these, in some way, could be referred to as a house or a home. However, you're not going to secure all of these things the same way. You're going to want to protect your primary residence more than your kid's backyard igloo when we got that week of snow and the kids would not go back to school. These also have very different safety and security concerns that are inherent to the type of dwelling that it is. With the treehouse, you got to worry about somebody falling out. With an apartment, you got to worry about somebody in a unit next to yours being stupid and putting your unit at risk. And that's even before you start to consider environmental and location factors. Like here in Ohio, I have much different flooding concerns than I would if I lived in Miami Beach. So say that you tell your security engineer that you're building a system equivalent to a home, and that's all the information that you give them. Your security review is going to get real wild real fast. So your security engineer, they could give you requirements that are just totally misaligned to the risk profile, meaning you're either going to over-secure or under-secure that system, both of which are bad. They could really miss key threats that are relevant to you because they've made different assumptions. Or they could make suggestions on controls that just make no frickin' sense. What that means is when you are in that situation, you have to untangle all of that, and that is what starts to suck. So, when it comes to making a request for a security review, I have a couple tips. Like, one, don't give so little information that there is basically nothing substantial to review. That is the equivalent of your teenage son who just got his license telling you that he's going away with his friends for a couple of days. Like, I hope you would want more information before you say yes to that. But also don't give so much information that you are forcing them to go through like this 3-day reading assignment before they even figure it out. You're basically counting on them finding 3 days of uninterrupted time, and that is most likely not going to happen, and that is just going to delay your security review. So instead, we're going to make it simple, and there are 5 ways that we can do that. So first, tell them what you are building and why. Importantly, make this no more than a paragraph. It should be able for it to click very quickly. Then help them visualize it. Show them what your system looks like. Show them the data flows. Show them the UX mockups that you have, because that's going to solidify their mental understanding. Then this next one might surprise you, but tell them how you view the security of your system. Tell them the security considerations you've already made and what you're worried about. And that's going to help them with their own mental model and also give some additional confidence that you've at least thought about this before you talk to them in the first place. Then give them other business context and drivers. Like, this is where, in our house analogy, you would tell them that you're going to build a beach house in Miami or a backyard tree fort you have no intention on moving into. And then, and only then, should you give them all of the links to the documentation so that they can do a deep dive. But what you're doing is you are helping them form that mental model, you are easing them in, and you are accelerating their ability to actually engage in the security review. The good news is that AI is really good at summarizing things, which makes your job of packaging and delivering this a whole lot easier. Now, you might be tempted to say, well, if it's so easy to use AI, then why can't AppSec use AI and create all of this summary context instead? And the reality is if you don't try to package that, they will try to do that. But the problem is they can't necessarily fact check it. And this is what's going to lead to bad assumptions, and bad assumptions lead to bad security review results and suckage for everybody. So again, we're going to leave the world of tech for a sec. And we are going to talk about what happened to me and my family on Christmas Eve of this past year. So hopefully not a spoiler to you, but I am Santa. I bought all of the Santa presents for my kids, and my youngest son wanted a Kindle. So one day he comes home from school. He had this handwritten letter, super cute. It was asking all kinds of questions, like if he and Mrs. Claus were related, how to tell the elves apart, and super cute. So my wonderful husband had a brilliant idea. He said, I can use AI to respond to this, and it will be a better Santa than you and I can be. Cool. So he asked Gemini to act like Santa and write a response letter. For context, he gave him the letter. He said my son wanted a Kindle and that he had been really good this year. So he pumped all that in. He got a letter in response, and he was super impressed. Like, the tone was perfect. It was exactly what you want Santa to sound like, and he knew our son would love it. But there was a catch. In the letter, Santa said, I will make sure the elves make you the perfect Kindle case to go along with your Kindle. I didn't buy a Kindle case. And so my husband was the one he didn't buy the gifts, but that meant that he wasn't in the position to be able to fact check that letter as easily as I could have if I had seen it before we gave it to him. And if you're wondering if at 6:30 p.m. on Christmas Eve, if you can have a Kindle cover delivered in time, the answer is no. But it was fine. Christmas was not ruined. We got through it. But this is why I always recommend that software engineers are the ones to aggregate this information, even using AI, because you can be the ones to spot hallucinations. You can see where your scope may have changed after you wrote all your epics or how you may have changed the design later on, but AppSec can't. And if they're operating on something that is outdated or flat out hallucinated, again, bad assumptions lead to bad results, which lead to suckage for everybody. So now I want to take a look at another step of the process. The reality is that if you are a software engineer, an engineering manager, product manager, you own the security of your systems and products just like you own the quality, the reliability, and their functionality. You don't have to wait on a security engineer to engage on your security review, and in fact, you really shouldn't. Most of us are familiar with something like this graph, showing that it's so much harder and so much more expensive to fix bugs the further you go in the SDLC. And this is especially true if the bug that you're talking about isn't just an easy logic flaw, but an underlying design or architectural issue. If you designed your system to be insecure, that 100x cost factor is because you might have to rewrite the whole thing, change the core UX, or even break customer workflows if you've already deployed it and it's already in your customers' environments. There's another kind of security flaw, though, and it's between that systemic design flaw and isolated vulnerability, and that's just missing security features altogether. Whether that's logging, authorization checks, rate limiting to prevent resource exhaustion. Those aren't always quick fixes, especially if you discover them right before you are about to launch and you have no time left. So that's why it's important to know and anticipate your security requirements in advance so you can factor them into your project plans, your backlogs, and your estimates. That way, no surprises before your launch, and nobody wants a nasty surprise before their launch. But how exactly do you do that? The answer in security is what we call threat modeling. Now, contrary to what you might think, threat modeling is not just for security experts. And in fact, I think that's one of the most damaging myths propagated by the security industry. You, as software engineers, engineering managers, product managers, BAs, you can and you should threat model your project. The reality is that you know your systems better than any security engineer could. If you recall that team that I told you about, the one where we had 3 AppSec engineers and over 100 engineering teams, well, we also had over 900 production microservices at that company. Those 3 engineers in security never stood a chance at having the same level of context or expertise on any given service that the software engineer teams had. Now, if you haven't done threat modeling before, I'm going to cover the basics really quickly. So simply, threat modeling is a process by which you identify what could go wrong in your system and you make decisions about what you're going to do about it. It's really that simple. You can threat model just by asking 4 4 questions. What are we working on? Which we just discussed, all about context. That all answers that first question. So we've got 1 down. What could go wrong? What are we going to do about it? And did we do a good job? Now, a lot of folks really struggle with that second question of what could go wrong. And there are several ways that you can go about that. My preferred method is Stride. And when I was an instructor for Showstack and Associates teaching threat modeling, I found Stride consistently to be one of the most intuitive for longtime builders. For me, I started my career as a software engineer. So if somebody tells me to think like an attacker, that's hard for me because I'm not one, and I don't feel that way. So Stride cuts through all of that. Stride is a mnemonic, and it stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Spoofing just means pretending to be somebody other than yourself. So if I masqueraded as Jonathan over there, that's me spoofing him. Tampering, though, is making unauthorized changes to something, whether that is code, your data, infrastructure configurations, resources. It can be malicious, but it could also be accidental, because who here hasn't left off a where clause from a SQL statement or accidentally committed to main by accident? Okay, y'all are liars. There are no hands. That cannot be true. So repudiation is claiming that you didn't do something or that you weren't responsible for an event. Now, those claims can be true, like disputing a fraudulent charge on your credit card that you didn't make, or they could be false, like that old Shaggy song, "It Wasn't Me." It was very obviously him. Information disclosure, easy. Revealing something to somebody who shouldn't be able to see it. Denial of service is either taken out or degrading a system so severely that it's practically unusable. And elevation of privilege is allowing somebody to do something that they aren't authorized to do. So as a normal user of a system, I shouldn't be able to run arbitrary commands. I shouldn't be able to execute admin functionality. Now, those are the definitions. But if that's still too attacker-like for you, instead of thinking about going wrong, think about what you actually do want in a system and build towards that. So, for example, you want to know who your users are. You want to know what they've done. You want to know that they've only done the things that they're allowed to do. You want data integrity. You want your system to be up, and you want sensitive data to remain confidential. So there's more to threat modeling, but give it a try. You know, once you've gone through Stride, you've basically answered that second question of what can go wrong. And then you can start to answer, well, what are we going to do about it? Now, the answer to that question can vary. There is no one-size-fits-all answer. The answer could be that you decide to do something about it, and you put it in your project backlog, you budget for it before launch. Awesome. Maybe preventing an issue is really, really hard, and so you decide that instead the right course of action is to be able to detect when that thing happens and know what to do and how to respond to it. Other times, it might just mean acknowledging that something could go wrong, but you accept that possibility. At the end, the most important part is to make an informed decision about the security of your system. Make sure that you've done what you can within your constraints and that you aren't surprised at the end. You can't always fix everything. If you tried, you probably wouldn't ship anything. When you ship software, there is always some amount of risk. And that is okay. Again, the most important thing is that you've actually considered your security and that you have been intentional and you aren't surprised. Now, what I will say is that you can do this process manually, and it is good to understand how to do it, but AI is also a useful companion too. So we've already covered 2 things at this point. We've covered the context aggregation, the package and the delivery, and we've already touched threat modeling, and those are 2 of the biggest things that you can do to make sure your security reviews don't suck. But there are also 3 much easier and quicker wins that you can have. The first is to just do the basics. If you are shipping production code, make sure your main branch is protected. Make sure that you've taken care of at least the big and obvious critical and high vulnerabilities that your SCA tool or your dependency scanning tool has flagged, and use relatively recent versions of your libraries. Have runbooks in place, make sure you got logs so that if something bad happens, you can figure out what happened and you can figure out what to do. What all of this does by covering the basics is it gives your security team the confidence that you at least have a minimum security bar in place. That means with that confidence, they're going to focus their review on the net new high value stuff, like the actual feature you are trying to ship in the first place. If they don't have that confidence, they are going to scrutinize everything. They are probably also going to find a lot, because if you don't have the basics in place, there are probably many other things that aren't there. What that's going to do, that's going to make your security review take forever, and you don't want that. Cover the basics, give them that confidence. The second is to get your timing right. Now, you can't always give ample notice about a high priority security review. Maybe you were given an impossible deadline yourself. Maybe you underestimated the work. Either of those situations, they happen. That's just reality. But as we've seen, the security review process isn't small. This isn't a checkbox activity. If you know that you have a time-sensitive review coming, give them a heads up and give them what you can. Say your scope is pretty set, but you're still trying to flesh out the final code tweaks. Submit the request anyway so AppSec can at least do their prep work, which is over half of the review itself. And finally, don't fall into a trap. There are two common things that drive security engineers crazy when they hear them. The first is that when you assert that a bad security outcome will never happen. Security people, we are trained that it's not a matter of if, but when something bad happens. And security people, they're also dealing with your company's entire software portfolio. They're not just dealing with yours. So saying something like this, it's dismissive, and your security teams have probably had multiple occasions where people have told them that something will never happen, and then it did. All this serves to do is create conflict. And when you have conflict and you have bickering, what you aren't doing is actually making progress on the security review, which is the thing that you want to get done. So instead, you can argue that the likelihood of something is low, and you can give your reasons. But then acknowledge that it actually could happen, and make sure your leadership acknowledges that and is willing to bear the responsibility for collaborating in a response if something happens. That's it. This can be a collaborative partnership. Your security teams, as much as they would like every security risk to be addressed, they also know that that's not possible, but don't be dismissive about it. And then there's the argument that your system or your product isn't important enough to attract attacker attention. Again, your security team is focused on the entire attack surface. They see your company as a system of interconnected parts, not your specific isolated system that can't touch anything else. In fact, a lot of the worst security incidents have been caused by old or uninteresting systems that are seen as an initial target for an attacker and provides a gateway to the rest of the ecosystem. So, same as before, it's just a lot easier to not go down this path in the first place. When you say something like either one of these, your security engineer might feel like they have to compensate for that flawed logic, and again, that will come at the expense of getting the security review done. And there you have it. You know, at the end of the day, application security, it's a team sport. It's on you as the owners and engineers of your systems to make sure that security does have the same weight as quality and reliability and functionality. And your AppSec teams are there to provide you with support. Again, this is not just a one-sided issue. In this room, all of you have the power to make security reviews suck less by changing the way that you engage with security. And security teams have a lot of ways that they can make these better too, whether that's using the same AI tools that you all are using to accelerate your development by accelerating and automating a lot of their security review work. At the end of the day, what we should be doing is working with one another and not against each other. We know that sometimes the security review system itself sucks, but there are a lot of things that both sides can do to improve the common experience and have better collaborative partnerships with one another. Together, security teams and software teams, you can come together to make it suck a lot less and do what you really wanted to do in the first place, which was to ship quality, awesome, and secure software to your customers. Again, I really appreciate everybody who has come to join me today. I am both encouraged by the number of people who are in this theater and a little bit disheartened based on the fact that it means we've probably all experienced a system that sucks. I hope everybody here feels empowered to make changes in their own engagement model and to help us prepare for the new era of software engineering where we do have AI coding assistants so that we can actually make the system better and not make it worse. At this point, I think we have a decent amount of time for questions, and so happy to take any. Thank you. Yes?
Have you worked in an environment where the security team feels like 2000s or 90s security or technologies are the best way and modern technologies are not inherently evil or unsecure?
Yeah, so for those in other theaters, the question was, have I worked for companies where the security team seems entrenched in the technologies of old and really, really hates the new ones? Yes and no. So I've been fortunate that my last two companies have been very tech-heavy companies. And so those types of companies do tend to attract people who want to play and tinker with technology. Now, that doesn't mean that they're not necessarily afraid of different aspects. So even with the dawn of all of these AI coding assistants, they can do really great things. We have also seen all of the horror stories about the lack of security guardrails. And so it's not necessarily that teams are anti-AI, but it's how do we do this securely? But sometimes that does come at the expense of, well, how do we navigate with velocity in the meantime? I have been fortunate that I have not had to interact with anybody who's like, oh my gosh, the cloud is evil. We should do everything on-prem or on data centers. I'm sure that is probably an experience that other people have had. And if so, that probably even more contributes to the suckage. Oh no, the head nod makes that a little disheartening.
If we go back to the stride slide, which one of those is most difficult for the app developers to comprehend, wrap their head around?
So the question was, looking at stride, what is the most difficult for software engineers to either comprehend, wrap their head around, or do something about? So I've taught over 15 threat modeling courses. And what I do typically find when it comes to just a conceptual understanding, repudiation trips people up as a concept every time. And part of that is because when people hear threat modeling, they assume that everything has to be malicious. You know, like we talked about, repudiation could be very legitimate of, I literally did not do that, that was somebody else, or I did not receive that package, like it truly didn't come in the mail. Or it could be something that was very legitimate in the shaggy, he absolutely did it even though he said he didn't. The good news is that even though a lot of people struggle to comprehend what repudiation as a threat means, a lot of times the mitigation for this one is one of the simplest. If you have good audit logs that prove what people did and didn't do, then you are able to, even if somebody makes a claim, you can help validate whether that claim is true or false. And that, as a system owner, is ultimately what you want to be able to do. So let me see if I understand. So you've got a security team and you've got an engineering team, and walk me through the rest of the scenario?
Yeah, go with that. So the security team is a part of the engineering side.
Okay.
But then the DevOps have nothing, right? They're just coding, doing their thing. And the security team pretty much focuses on the network, the Linux, Windows security, stuff like that. How would you start to approach the developers?
Yeah, so the general theme of the question is, you've got these different siloed organizations. How do you, with their different focus areas, and how do you help them work better together? The simple but boring answer is that I often tell people, you just gotta talk to one another. Like, we as engineers on both sides, sometimes we want to have like a technical answer to everything, and sometimes the people part of that equation is just as important. So not necessarily going along with the networking example, but at one of the companies that I led, security people think they understand what a good software development lifecycle looks like, and they're like, yes, I know what you do. You do the design and you work on your requirements, and then you have your mock-ups and all of those types of things. And what happens is they anchor in that mental model, and if that's not actually how software development gets done in your organization, bad outcomes happen. So an example of this in my career was at a previous company, we actually taught our software engineers the threat model. It was that 3-person AppSec team, 100 engineering team organization. And at first, everybody said, oh, you know what? We are going to do threat modeling. You should do it at design time. That makes sense on so many levels and on paper. But the problem is, our engineering teams were in more of an agile rhythm where in their minds, they didn't have design time. They had design on each individual story or epic that they did, but it wasn't like this massive ceremony. And so the result was engineers were saying, hey, do this at design time. Security engineers said that. Software engineers were like, that's not really a thing. And at the end of the day, threat modeling wasn't getting done. It didn't happen until we actually sat down and said, how does software get built at this company? Like, what do you do? And then we're like, oh, what we are thinking of as design time, you've actually have an architecture diagram creation. You don't call it design time, but that's where you should do your threat modeling. And then all of a sudden it happened. And so typically when there are organizations that are broken apart based on whatever their organization looks like, it's a matter of just figuring out, I don't care about the theory. How does work actually get done? What are the problems you actually have? And how can we go about addressing those? Well, thank you. Yeah.
Software engineer.
Awesome.
So, across multiple companies I work for, when I engage security, they typically have a really big band hammer. And
Okay.
I'm more than willing to use this band hammer at every turn. How do I talk to security so that they are less likely to just straight up band hammer me, and then I have to run a circumvent, right? And I go up the chain, and then they get overruled, but it's a whole thing.
Yeah, so the question was, we have a security team of no with a band hammer. I love that phrase. I'm going to use it now. And so how do you actually work with your security team to figure that out so you just don't get an escalation city? And so one of the things that I like to do when I talk to either team is be like, what are we trying to accomplish and why? And how could I do this securely? So a lot of times when I see a band hammer, it's for a couple of reasons. One, maybe you're in a super regulated environment, and that's an environment that is known for band hammers. You're shaking your head, so I'm going to assume that that's the case. And so again, it's hey, here's what I'm trying to do. How do I do this securely? Not, I want to do this, and they just say no. When you ask the how versus can I, you actually get to a better answer, because then you're both collaborating to solve a problem, and it doesn't feel like you're seeking just an approval.
Can I ask a follow-up to that? How is that realistic when you have those ratios that you were talking about at the beginning, right? I think we all love to collaborate. I like to collaborate with various partner kind of sections of a company. But if they don't have time or they're overworked, what do you do then when you have those ratios that you were talking about?
Yeah, so
Sorry.
no, you're good. I'm just repeating for the folks in the other theaters. So the question was, how do you actually have those collaborative engagements when you have wacky ratios and you have a very small security team and a very large engineering organization, and there are time constraints to make that happen? I like to think about that as going back into, you can still ask the question of how, but that is where both the How do we communicate context and package that as small as you possibly can, followed by doing your own threat modeling can help. When a security engineer is like, oh my gosh, they haven't even thought about security in the first place, I gotta do all of this work before I can give them any answer at all, that's going to make things a lot worse. But if you're like, hey, package it as small as you can so it's easy to digest, and they're like, all right, let's talk. Then you can start to say, all right, here's the threat model that I've actually made about this. It is when, even in dealing with, in my own career, when I'm dealing with a team and I know like, oh man, they actually do think about security and they care about it, things go a lot faster than when like my team feels like, oh my gosh, this is one of our problem children. They have incidents all the time. We are paged at all hours, and so we have to apply even more scrutiny here. Looking at our time. All right. Yes.
On my last job, I had an experience where we had an automated code scan that we ran after code completion, and it found like 100-something false positives, and I had to go through and document every false positive and the explanation for why it was a false positive, and it ended up being like over 100 pages in a Word doc, and I was just thinking like, why are we even using this automated software if it's coming up with so many false positives? Like, where would you have gone? Or like, what decision would you have made, or suggestion you could have made to like management so that I wouldn't have had to make that happen?
So the situation here is a common one, and it's a case of you have a very noisy, high false positive security code scanner followed by a very cumbersome process to document that all of those things are false positives. Made even more complex by the fact that the scans are running after code complete, and so you're dealing with a burst of things at once. Unfortunately, this is pretty common, and one of the major reasons why is that if you are in a regulated environment, FedRAMP is one of the biggest offenders of this, where they require that you run all of your code scans and you have very cumbersome explanation processes for false positives. Actually, the reducing risk one, if you're like, this says it was a high, but it's really a low, that one is a nightmare. And so part of it is that our well-intended regulations have often imposed these security constraints where even your security team does not love this. I have unfortunately been a part of that. Now, there are things that you can do. Like if you work with your security team and you're like, hey, instead of this like massive effort post-code complete, it would have actually have been more sustainable if we had known about these all throughout. How can we actually maybe get those scans to happen earlier in the process? That can distribute it and make it less of a nightmare. If you work with your security team and if you start to see trends and like you're like, here's this entire class of false positives, you can work with them so that they can actually tune those out of your scanner and try to get like a bulk justification for like, this is always a false positive class, here is why, and then you don't have to do it for each vulnerability. Ideally, your tool should also be able to have the ability to mark those things as false positives so that the next time you release, you're not justifying the same ones over and over again. One of the things that I am intrigued about in the industry is more and more of those scanners are starting to bake in additional intelligence, using AI to be able to say like, okay, sure, on first glance, this looks like it's an issue. However, if it's like a third-party library, it has reachability analysis. So we know that part of the code's never even touched. So those things can generally get auto-closed in a way that provides that defensibility. So provide that feedback to your security teams, though. They might know and be like, yup, it sucks. Or maybe it's something that they can actually do about it, because even as a security person, I have been the security person telling people that I'm really sorry, I have to do this, but let's figure out how to make it suck less.
Thank you.
All right, I think that brings us to the end of our time. It was so great chatting with all of you, and hope to see you around the rest of the day.